Okay, periodic trends. Let's look at this. This is a graph of the ionization energies for the first 20 elements by atomic number. Okay, and we can see that ionization increases here. So these would be the high ionization energies. And atomic number is increasing here, and then we can see W's the lowest ionization energies. So let's try and figure out which one is X and which one's W by looking at this periodic table of the first 20 elements. So if we look at it right here, notice the numbers are low over here, but as we're coming across, they get bigger, right? So the trend is they're increasing going this way. And also notice they're increasing going up a group, which would match what we have here, right? Because helium should have the highest ionization energy. So looking at that, we can see that 237, these are the actual ionization values. So notice group 18 has the highest ionization energy. So looking at this, that would mean X would be group 18 or the noble gas family, right? All right, and then the lower ionization energies would be over on this side, right? And who's that group 1? Group 1 are the alkali metals. All right, and then everybody else would fall in between there. Okay, there's a test question just like that. Okay, let's look at this atomic radius. On these, we're going to figure out which element for each pair has a larger atomic radius. So again, we're going to get this, and we're going to see the larger ones are over in this corner, except francium is not the largest. Cesium actually is. So let's compare, like here, nitrogen, fluorine, they're in the same period, right? They're in period 2. If the trend is going this way, that would mean nitrogen has a larger atomic radius than fluorine. So that's what you're going to do for each one of these. Same thing here for each group of atoms. Circle the atom with what? The largest atomic radius. So you're going to get on here and compare those 4 elements right here. Who has the larger atomic radius? 14 is the largest ionization energy, so you'll be using this one. Smallest atomic radius and smallest ionization energy. So you're just going to look at this table and compare those. There's a bunch of questions like that on your test. Okay, and then you can answer this question because iodine is in group what? 17, so he would have properties like which one of these elements? Okay, on this page here we've got ionization energies and electronegativities for a set of atoms, and you are going to find that set of atoms on here. Let's take, for example, magnesium. We've got magnesium, calcium, and barium. Okay, so I've got magnesium, calcium, barium. They're all in the same family. And then what do we know? They increase going up. So we want to rank them from lowest to highest ionization energy. So if it increases going up, that would be the least, then calcium, and then magnesium, right? Okay, so you're going to do that for each set. Also, the same thing down here for electronegativity. Okay, so right here, when we're doing these, I just want to remind you that noble gases have 0 electronegativity because they don't do any bonding, so the higher electronegativities are going to be the halogens. Remember that when you're doing this.